First of all, before we start the topic of electric current, we know the basic structure of an atom. Okay, an atom will contain a centrally placed nucleus in which protons and neutrons will be there, and of course there will be electrons in various orbits. These electrons, depending upon how many electrons are there in the outermost shell or outermost orbit, depending upon that, that substance is going to be a good conductor or poor conductor or an insulator. It means if it is a good conductor of electricity, it will allow electric current to pass through it. If it is not a good conductor of electricity, there is going to be opposition for the flow of electric current. Basically, what is flow of electric current? In general, if we are speaking through a metal wire, these electrons are going to change its position. It means suppose here this is a metal block. This is a metal wire. You know, there will be trillions of atoms. There will be a centrally placed nucleus and electron is going to be there in the outermost shell. In this way, there will be trillions and trillions of atoms together, positively charged nucleus and an electron. Now, suppose if I am applying positive and negative terminal over here, it means I'm connecting this to a battery. Obviously, on the right hand side, you can see over here. Okay, there is a negative charge. It means here it is going to push these electrons. So because of this pushing of electrons, what will happen? That atom, the first atom which is there, it is going to have an excess electron. What it is going to do, it will push that electron to the next neighboring atom. It will push that electron to the next neighboring atom. In this way, the electron is going to travel from one end of the metal wire to the other end. Basically, this is how electric current, that is the flow of electrons taking place through a metal wire. There are different ways in which electricity can pass through. We'll see those methods also, electric methods, flow of electric current through solutions also. That part also we'll see, but at present we are just dealing with the circuits, that is flow of electricity through the wire. So the first part that we are going to do is we are going to write down the definition of electric currents and its associated or relative definitions. Okay, so we are discussing here flow of electric current through a metal wire. Electric current, first of all, the definition is the rate of flow of electric charge. It means how fast the charges are going to flow. Okay, so this means how fast the electric charges flow. Electric current is measured in the unit that is called as amperes. There are smaller units, okay, which are known as milliamperes. This conversion also I'm going to show, which you are going to take down. Okay, electric current is measured by the device which is called as ammeter. Okay, I'll also draw the symbol of this ammeter. So these are the parts that are taken over here. Electric current definition, rate of flow of electric charge means how fast the electric charge flows. Electric current, this is measured in the unit which is called as amperes. Its symbol is capital A. There are smaller units that are milliamperes. The conversion is 1000 milliamperes will be equal to 1 ampere. This is the circuit symbol of ammeter. Positive and negative terminal will be there. And if I'm going to draw a simple circuit diagram, as you can see over here, this is the symbol of cell. I'm going to make you draw afterwards, and you have to learn also all the circuit symbols which we are supposed to do. Basically, what is an electric circuit? An electric circuit is a path through which the current flows. The basic thing is going to be the cell. Obviously, this is the source of electricity or source of energy. The longer line over here is representing the positive terminal. The shorter line over here is representing the negative terminal. Okay, the positive terminal which is there, in that case, I'm supposed to mark an arrow like this. Now, this does not show the flow of electrons. It shows the flow of conventional current, which is assumed to be the flow of positive charges. In reality, what is happening? In reality, the electrons are flowing in the opposite direction, that is from the negative terminal. Here another circuit symbol that you are seeing, that is switch. When this line is not touching, it means this is switch open. When this line is going to touch both the circular parts, in that case current will be flowing and the switch will be closed. In that case the current flows. This is the symbol, circuit symbol for bulb, and the bulb will glow. That was about conventional current, so that part is also important. Okay, I just made a note of this. Conventional current is assumed to be the flow of positive charges flowing from positive terminal to negative terminal. Okay, as I've said earlier just now, it is opposite to that of direction of flow of electrons, which is from the negative terminal to the positive terminal of the battery. You're going to take down all of these things from here. If you have any questions, you are going to ask me, and then we are going to come to different type of circuit symbols, and of course different type of circuits also, parallel circuit, then series circuit, and what is going to be the differences between all of them. You can start taking down all of these things. I'll give you some time. Okay, this is the definition of electric circuit. Electric circuit is the path through which the current flows. Electric circuit consists of components of electric circuit which are represented by circuit symbols. Okay, I'll just show you that circuit symbols, which you can take them down and you need to know all of them. Apart from this, some extra information is there. Touch screen works using electric charge. There are devices which are known as capacitors that can store electric charge. Digital images are made up of picture of elements called pixels. This is generally where we are operating the mobile phone camera. The digital camera contains a grid that produces a charge when light hits it. So this is about some other basic important things. These are the circuit symbols, components, which are going to be important. The definition of electric circuit is also again given over here. You can take that down. About the circuit symbols, a straight line is representing the wire. A longer line is representing the positive terminal of the cell. The shorter line is representing the negative terminal of a cell. When more number of cells are connected together, this dash 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 means there can be 3, 4 or more number of cells together connected. So it is going to supply more current as well as more voltage. This is the symbol of lamp or an electric bulb. This is open switch. It means the current cannot flow through this part of the circuit. And this is closed switch. It means the current is flowing through that part of the circuit. This is a buzzer. Normally it is going to be a bell. Okay, sound which is generally used in alarm. And this is a symbol for motor. If you have any questions, you can ask me, or else you can take down this definition of electric circuit, and also you have to draw all the circuit symbols. Okay, now what are conductors and insulators? Conductors will be those substances or materials through which electric current can flow or electric current can pass through. Most metals will be good conductors of electricity. There is an exception, graphite, which is a form of carbon, an allotrope of carbon. That is also a good conductor of electricity. Then those substances which do not conduct electricity, they will be known as insulators. So electric current cannot flow through them. Simple examples of these are rubber, plastic, wood, and glass. Okay, so these are the substances which are conductors as well as insulators. The next part that we are doing is the types of circuit. The first type of circuit is a series circuit. Here all the components are connected one after the other. I'm making a simple comparison of, there are 3 water pipes. This is pipe number 1. This is pipe number 2. This is pipe number 3. Okay, there is a huge tank over here in which a large amount of water is there. There is a motor which is going to pull this water from the tank. And first of all, this water is flowing through the first pipe. And then water flows through the second pipe. And then water starts flowing through the third pipe. And then of course it is returned back to the tank. So here water is flowing through the pipes one after the other. I'm making a similar comparison of 3 bulbs that are connected one after the other. Okay, here obviously you can see there is a positive terminal, here there is a negative terminal. So the first current is going to flow through, obviously this is a measuring device, ammeter, which measures the current. So the current is going to flow through the first bulb, then it is going to flow through the second bulb, and then it is going to flow through the third bulb, and then it is going to return to the battery. This is the first kind of a circuit, which is series circuit. And here the current is flowing one after the other through each of these components. Of course, there is afterwards a second type of series also. We are going to see what are the advantages as well as what are the disadvantages of the first type of circuit, that is series circuit, and the second type of circuit, which we will be doing later, that is a parallel circuit. And then we are going to write all the differences between series circuit and parallel circuit. You can take down this diagram, and then I'm going to make you write all the other points, and we will discuss all the differences between all of them. Okay, so this is, we are doing one numerical that is based on current, voltage, and resistance. Potential difference will be measured in volts. Of course, we are also going to come to these terms also. But first of all, let me get that numerical. Okay, I'll just put write that numerical over here. Calculate the current in the circuit whose potential difference, that is voltage, is 15 volts, and its resistance is 1000 ohms. Afterwards, we'll do some examples of series and parallel also. So the next part that we are doing over here, we are going to apply the formula. Okay, what is the formula that relates these three values? V is equal to I multiplied by R. Okay, V is potential difference, that will be in volts. I is current, that is going to be in amperes. R is resistance, which is going to be in ohms. Okay, yes, you do have a shortcut that is there in the textbook as well. So your voltage is 15 volts. This is equal to, I'm substituting here, I is the value that we are supposed to calculate. R is resistance, which is 1000 ohms. If I rearrange the terms, I is equal to, this is going to become 15 divided by 1000, okay, which is going to be 0.015 amperes. Sometimes they may ask you to calculate in milliamperes. So straight away again, if you are going to multiply it by 1000, this is going to become 15 milliamperes. Okay, we are having several kinds of numericals. Some of them are based on series as well as parallel circuit, which we are going to do in our next class. You can just take down that numerical. We'll continue in the next class.